Hello ma'am. My first question is, what is reversible adiabatic process and what are the important characteristics for this process? Second question, please solve one problem on isentropic process and show this process on the pressure volume diagram, temperature entropy diagram and enthalpy entropy diagram.
Reversible adiabatic process or isentropic process is the process when entropy remains constant. Now we know that when the heat is getting absorbed or when the heat is getting removed, then there is the change in entropy. But in this process entropy remains constant, and that's why there is no any heat transfer is taking place. Now what is the meaning of reversible adiabatic process? So when there is no any friction in the process, and this process is known as the reversible adiabatic process. When the friction is involved in the process, then that process is irreversible adiabatic process. Now we can say that in the isentropic process entropy remains constant, and for reversible adiabatic process there is no any friction is taking place. Now the heat transfer during the process 1 to 2. So 1 is the initial condition of steam and 2 is the final condition of steam. So heat transfer, that is Q12 is equal to 0. Then how to calculate this work done? So what is the formula? So formula we know that Q12 is equal to du plus W12, that is heat transfer is equal to change in internal energy plus work done during the process 1 to 2. Now here Q will become 0 because there is no any heat added or removed in the process. So no any heat transfer. So we can say that W12 is equal to minus du. Now what is the du? That is the change in internal energy, and which is equal to U2 minus U1. So I will say that minus in the bracket U2 minus U1, which is equal to W12. So I can write here W12 is equal to, so if I multiply this minus sign inside, then W12 is equal to U1 minus U2. So these are the formulas that we have to consider while solving the problem on isentropic process. Now we will solve one problem and we will understand the initial condition and final condition of steam, or we can say process 1 to 2, with the help of pressure volume diagram, temperature entropy diagram and enthalpy entropy diagram. I will read what is the given question. Steam from an initial pressure of 7 bar and 200 degrees Celsius is expanded isentropically to a pressure of 1 bar. Calculate final condition of steam, change in internal energy, work done during the process. So this was the given question. This is the isentropic process. Let us first understand the initial condition and final condition of steam with the help of steam table. Now initial condition, pressure is given 7 bar and temperature is given 200 degrees Celsius. Now if we refer here the pressure table, then we will compare here the temperature, that is at the pressure of 7 bar what is the saturation temperature. It is 165 degrees Celsius. So here it is given for 7 bar pressure temperature is 165 degrees Celsius. But this temperature is greater than this saturated temperature. So we can say that this T is nothing but T superheated. And this initial condition of steam is the superheated steam. So I will write in the bracket, this is the superheated steam. Now we will move for the final condition of steam. So final condition of steam, pressure P2 is 1 bar. Now for this pressure P2 is 1 bar, the entropy will remain constant as that of for the initial condition of the steam. So for how to find out this entropy? So entropy will be S superheated. So we will find out the specific entropy of superheated steam. So here at the end there is the table, that is the specific entropy for the superheated steam. So here we have to take pressure 7 bar and temperature 200 degrees Celsius. So on the vertical line in this table, here pressure is given, and on horizontal line there is the temperature given. So for 7 bar pressure and 200 degrees Celsius, the entropy is given 6.886. So this is the entropy is superheated, and this entropy will remain same for the final condition of steam. But for final condition of steam, pressure is 1 bar. So we will again refer this pressure table for 1 bar. So here is the pressure table for 1 bar, and now we will compare this as superheated. So for this pressure table 1 bar, this entropy of the saturated, dry and saturated steam, it is 7.360. So if we compare this 7.360 and 6.886, then this entropy is less than the dry and saturated steam. That means we can say that the final condition of steam is the wet steam, because the entropy, that is S superheated, will remain constant because this is the isentropic process. And what is the entropy of dry and saturated steam? That is 7.360, and it is less than this dry and saturated steam. So this steam is the wet steam, and here entropy, that is S superheated, we have to take is equal to 6.886. Now what is the final condition of steam? So final condition of steam, that is for the wet steam, what is the dryness fraction that we have to calculate? So how to calculate the dryness fraction? So this S2, that is nothing but S superheated, and for wet steam, what is the formula to calculate the entropy? That is SF2 plus X2 SFG2. Now this SF and SFG value we have to take from a pressure of 1 bar, because here the pressure is given, that is 1 bar. So here SF value 1.303 and SFG value 6.057, that we have to take, and we can calculate here X2. So S superheated, that is we have to put, and X2 is equal to 0.92. So this is the answer of first question. Now we will calculate the next question, that is the change in internal energy. So change in internal energy, that is U2 minus U1. So how to calculate U1? So at the initial condition, steam is superheated. We have formula H1 minus 100 P1 V1. So pressure is given in bar, and we have to take here pressure in kilopascal, and that's why we have to multiply here with 100. So whenever pressure is given in bar, then we have to take this formula H1 minus 100 P1 V1. So for superheated steam, we have to take H superheated minus 100 P1 V superheated. So at a pressure 7 bar and temperature 200 degrees Celsius, what is the enthalpy? So for that we will refer here the superheated steam table for the enthalpy. So we have to also take the superheated steam table for the volume. So for enthalpy, if we observe for 7 bar pressure and 200 degrees Celsius. So here is the, on vertical line there is 7 bar, and on the horizontal line 200 degrees Celsius temperature is given, and 2844, this is the enthalpy. Minus 100 into pressure, that is 7, multiplied by specific volume. So in the same way, here the volume table, specific volume table is also given for the 7 bar. So here 7 bar pressure and 200 degrees Celsius temperature is given. Here 0.299. So we will say 0.3. So which is equal to 2634 kilojoule per kilogram. Now we will calculate U2. So U2, that is final condition, is the wet steam. So how to calculate the enthalpy for the wet steam? So H2 is equal to HF2 plus X2 HFG2. Now this HF and HF2 value we have to take for a pressure of 1 bar. So we will refer here the pressure table, and for the pressure of 1 bar we will take HF, that is here it is given 417.5, and HFG, that is 2258, the value is given. Now here P2, that is pressure is 1 bar, and V2. So how to calculate the specific volume, that is X2 Vg2. So Vg value is also given for a pressure of 1 bar, that is 1.694. So we have to take this value. So calculation is, so after calculation we will get 2339 kilojoule per kilogram. Now we will calculate here the change in internal energy U2 minus U1, that is equal to minus 295 kilojoule per kilogram. So this minus sign will show or indicate there is the decrease in internal energy. Now we will show the process, that is process 1 to 2 on this pressure, volume and temperature entropy diagram. So here initial condition of steam, that is it is superheated steam. So we have to show this in the superheated region. So say suppose here is the pressure of 7 bar, and here I will say this will be the initial condition of the steam, that is in the superheated region, and final condition is the wet steam, and we have to show at a pressure of 1 bar. So suppose at the bottom there is the 1 bar, at the bottom we will take here the 1 bar pressure line. Now we know that here is the decrease in pressure. So whenever pressure is getting decreased, there is the increase in volume. So we have to show increase in volume. So this will be the point 2. Now I will join this point 1 and 2. Now this is the volume V1 and here is the volume V2. In the same way, here is the pressure P2 and here is the pressure P1. Now we will show this temperature entropy diagram. Now here temperature, that is T superheated 200 degrees Celsius is there for the initial condition, and for the final condition of steam we have to take the pressure at 1 bar. That is, if we refer here for wet steam, what is the saturated pressure, then for 1 bar pressure we will take here the 99.63, that is the temperature, that is there is the decrease in temperature. So in superheated region we will take here this T superheated. So in superheated region we have to take temperature, that is 200 degrees Celsius. We will select here the point 1. So for this point 1 there is this temperature is known as T superheated. And then final condition of steam is wet steam. So here is the wet region. Now most important thing is that entropy will remain constant. So we have to show the entropy constant, that means straight vertical line. So I will show here the straight vertical line, and for the wet steam what is the saturated temperature, that is 99, that is approximately 100 degrees Celsius. So I will say here as a that is the final condition, that is T1 and T2, and here is T1, that is equal to T superheated, and I will show arrow also. So here is the process on temperature entropy diagram. For the isentropic process, work done is equal to minus du. So here minus and du is in having minus sign, so we will write inside the bracket minus 295, and work done is equal to plus 295 kilojoule per kilogram. Now we will show the process 1 to 2 on this enthalpy-entropy diagram. So how to show? So for the initial condition, pressure and temperature is given. Now this point 1 is in the superheated region. So if we will say here are the pressure lines on this enthalpy-entropy diagram. So see, this is the line for the 7 bar. And for this 7 bar there is the temperature of 200 degrees Celsius. So there are the horizontal lines here, that is for the temperature lines 200 degrees Celsius. So this point of intersection will be the point 1. Now in the same way, for final condition of steam, pressure P2 is 1 bar. So here is the line 7 bar. So parallel to this line, suppose here is the line for the 1 bar pressure. Now there is the dryness fraction is also we have calculated for the wet steam, that is 0.92. So at the bottom here are some inclined lines that are for the dryness fraction x is equal to 0.92. So I will say that here x is equal to 0.92 line, and this point of intersection will be the point 2. So in this way, this point 1 and point 2 is getting selected in the molecular diagram, or we can say enthalpy-entropy diagram. Now we will show this process 1 to 2. We will show arrow also.